Okay, welcome back. It's time to discuss a new topic in Java or a new topic in object-oriented programming. We are introducing the concept of inheritance. So far we have seen composition, and composition has a relationship. A person has a date of birth. So far we've been building classes with fields and behaviors using this has a relationship. We have built classes and composite classes. A composite class is a class made up of other classes, or a class with user-defined data type fields. So that's what we've done so far. Now it's time to introduce the concept of inheritance. Inheritance is this type of relationship. The relationship is a. The relationship is either pronounced is a or is a kind of or is a kind of. For example, let's take a field animal and maybe a cat. We could say a cat is a animal, or we could say a cat is a kind of animal. So that would define a relationship between a cat and an animal. For example, maybe you have a class called vehicle, and then you have another class called car. We can say a car is a vehicle, or we could say a car is a kind of vehicle. In this particular example, as we're going to see, the vehicle is called the superclass or the parent class, and the child is the derived class or the child class, and we'll go from there. So in inheritance, you could say that car inherits from vehicle since the car is a vehicle. In the above example, as I said before, the car is the child class, sometimes called the derived class. And in the above example, the vehicle is the parent class, sometimes called the base class, and I didn't type it here, but sometimes called the superclass. Here's the vehicle class. The vehicle class is going to have two fields. It's going to have a vehicle ID number, and it's going to have a date built. A car is a vehicle, so a car is going to have a vehicle ID number and a date built. So if a car is in a vehicle, it has everything the vehicle has and whatever fields the car is going to have in the future. It's going to be my car class, and my car class is going to have 1, 2, 3, 4 fields. Car has a make, a model, an engine size and horsepower, and a sticker price. And don't forget, a car is a vehicle. So when we make this car class, it will be completely disjoint, at least at the beginning of the vehicle class. Things to remember: that Java is a single inheritance language. That means that every class has exactly one parent. Not 2, not 0, not 3, but exactly a single parent. Every single class that we've been using to now has one and only one parent. In a language that is what's called a multiple inheritance language, that is when a child can have many parents. C++ uses multiple inheritance and Java does not. One can argue that multiple inheritance is better, but James Gosling, the inventor of Java, has proven that there is not a program that can be written in C++ that cannot be written in Java. Java, a single inheritance language, basically loses nothing but the complexity of C++. This multiple inheritance kind of starts to look like spaghetti. I have so many parents and so many children, I kind of lose track. And a single inheritance language is like top down, very easy. A parent can have many children. So one parent can have as many children as possible. A child will know who his one and only parent is, but the parent will have no clue if children exist. So the child knows his one or her one and only parent, but the parent has no clue if any children exist. Child knows of the one parent, parent knows nothing of the children. Let's stop this slideshow and we'll build the car and the vehicle classes. We're not going to use the keyword for now. Again, this is what a car looks like. And when we build these car and vehicle classes, we will add all possible, not just all possible validation, but all necessary validation. Remember, the validation is going to go in the setter. Okay, so hopefully you've been coding and you have a test class, a vehicle class, and a car class. In the test class, let's start in the vehicle class. In the vehicle class, you should have two fields. A string VIN, because you're not doing any math with the vehicle ID number, and year built is just a integer, so I have two fields, string vehicle ID and year built, both private obviously. I have a constructor here, one constructor, and this constructor is going to be a two-parameter constructor passing in the VIN number and the year built and using the setter methods to populate the VIN number and year built. Here is a setter method for the VIN number, and I check to see if the vehicle ID number is greater than 15. If it is, I say, hey, maximum vehicle ID number is 15, and I stay in this loop until I get a vehicle ID number 15 characters or less, and that's just an example of some type of validation. And here is my year built, and I can make this up to be anything I want, and all I did here was say the year built has to be between 1990 and 2019. In real life, that would not be the case, but here's my setter. My setter brings in the year built, tests it. If it's invalid, it stays in this loop, prompting the user for a valid input, and once I leave this loop, I have valid VIN number, and I just do the assignment. This year built gets year built. I just modified the toString just a little bit, and my toString says vehicle ID, and then a space, and then the vehicle ID number was built in a space, and whatever the year is. Here's my car class. My car class, there's the four fields: the make, the model, the year built, and the horsepower, and the price. To build a car, to build a car, I need make, model, horsepower, and price. Make, model, horsepower, and price. So here's a constructor to build a car. And I got lazy here. I did not use my setters. I should replace all of these assignment operators with set make, set model, set horsepower, and set price. And then down in my setters, not my getters, is where I should be doing my validation. I'm going to have my toString. We'll talk about that later, and that's the end of my class. So here I am back in my test class. My test class is going to be pretty simple. In my test class, I am going to, let's do this, as I said, pretty simple. So in my test class, I'm just going to make a single vehicle, a single car, Some of this code's left over, so let me delete this, and you'll see the red squiggly will go away. So I have my make, my model, my horsepower, and my price. So there's car, my car. I'm going to make a vehicle. And I believe a vehicle has a VIN ID number as a string and a year, and that should be make a vehicle. So I should have two objects. I should have an object called my car and my vehicle, and I could display those. Oops. This will call the toString in car. This will call the toString in my vehicle. And when I run it, I will see the car and the vehicle. The car and the vehicle. Okay, so hopefully you were able to go in Eclipse and build your vehicle, your car, and your test class. You were able to create a car object and a vehicle object and output them. Okay, so here comes the inheritance part. We know a car is a vehicle. That means a car has everything that it takes to make up a car, and a car has everything it takes to make up a vehicle. In other words, a car has all the fields from car and all the fields from vehicle, and a car has all the behaviors from a car and all the behaviors from a vehicle. A car is a vehicle. To create this is our relationship, we're going to need to add this new keyword called extends. We need to write it like this. Public class car extends vehicle. So car extends vehicle. This is the child. This is the parent. Car is a child of parent. This car extends vehicle, meaning this car has everything a vehicle has. And obviously, the car will have everything a car has. Derived class extends base class. Child class extends superclass. Let's pause this presentation and we're going to add the keyword extends to the car class. After the word extends has been added, restart the presentation. Then we're going to take a look and see what just happened. Does the code still run and compile? So here we are back in the car class, and we're about ready to say public class car extends vehicle. Public class car extends vehicle. Did you notice what happened down here? The second we did, this constructor no longer works. Let's do that again. Constructor's fine. We're going to add extends vehicle, and now the constructor no longer works. So the question is going to be, what just happened? What just happened and why? All right, so we're back in the PowerPoint. We're back in the PowerPoint, and let's move forward. So here's the answer to our problem. The answer is that when you now make a car, you must provide the constructor of car everything it takes to make a car and everything it takes to make a vehicle. In the constructor below, you only have what it takes to make a car. So I have it takes to make a car the make, the model, the horsepower, and the price. That's the old constructor. This does not work anymore because now to make a car, I need the VIN number and the year built. Because now cars have everything in car and everything in vehicle. So I'm going to need to modify the constructor in car so that the first line is called the super constructor method. What I want you to do here when we pause the show is I want you to delete the constructor method in car, delete the constructor method, go back. I want you to delete the constructor method in car and then use that source feature to remake that same constructor, and then let's look at it and discuss. So I'm going to So what we should have just done is we should have came in here and wiped out this constructor method and then redid it using source. So I'm going to say source, generate constructor using fields. I'm going to make sure everything's checked, and I'm going to say OK. Take a look at what just happened now. Here's the same constructor that we had a minute ago, but this time it has in the parameter list the fields from the parent, the vehicle ID number and the year built. The first line in the constructor is a call to super. If you remember all semester long, and we've been deleting it, it looks like this. The first line was a call to the super like that. That call from the super was the constructor and object that we just totally ignored, and it doesn't really need to be there. But we've always had a call to the super. We're going to override or replace that with the call to the super. So this is calling super, which is vehicle, constructor, and creating a vehicle with the VIN ID and the year built. So now a car has everything in vehicle, vehicle ID, year built, and the make, model, and horsepower of the car. Everything in vehicle, make, model, and horsepower of a car. Remember, a class can have many children. So for example, a car is a vehicle, a bicycle is a vehicle, a plane is a vehicle, a truck is a vehicle. I don't care. You could say a skateboard is a vehicle. You could say rollerblades is a vehicle. Maybe not. So any parent class can have many children. Okay, now I'd like you to go into your toString in car and either delete it or comment it out and then run the program. Go into toString method in car, delete it, and run the program. I want you to tell me what happened. We're going to pause and test this. So I'm going to pause. Go ahead and do that and run it. Run your code and tell me. So I'm going to go in the car class and I'm going to either delete or comment out this toString method. So the only toString method that exists in this project is the toString method here from vehicle. So I am going to be in my test class. I still have my car, I still have my vehicle, and I'm going to output my car and my vehicle. Let's see what happens when I run this. Get an error. Okay, I did not change this code, so remember, when I make a car, I need everything from vehicle, which is the VID number, and the year built, plus everything that makes a car. So that when I call the constructor of a car, let's just take a look at that. When I call the constructor of a car, it's able to use that vehicle ID number and that year built to call the constructor of a vehicle and make this all work. So I'm going to go back in my test class, and now I'm going to see if this runs. And it does. Pardon me, this was left over from other work. So the only thing that we just saw, and this is, again, I was doing something, is these last two lines. Vehicle ID 99. Vehicle ID 45 was built in 1999, and Vehicle ID 1, 2, 3, 4, 5, 6, 7 was built in 1999. So where did this come from? Where did this come from? This came from a call to the only toString that's available. So in car does not have a toString method, but its parent vehicle does. So since it could not find a method called toString in car, it ran this one, which produced vehicle ID was built. When I bring the method back from car, when I bring my toString method from car, and notice my very first thing in car is a call to my supers toString, which whatever my super is, because remember that this child, it could be any child, and it could have a parent of vehicle. So let's watch this run. Let's watch this run. So now, when I run this, I have vehicle 1, 2, 3, 4 was built in 1999. Is a Honda Fit, horsepower 200, price that, and then the vehicle ID. This was built here. This called the toString in car. It did not call the toString in vehicle since one existed in car. This vehicle has nothing to do with car. It doesn't even know car exists. Called the toString in vehicle. Let's talk about method overloading and method overriding. We know what method overloading is. Method overloading is when you have multiple methods in the same class with the same method name, but a different signature. We've done that with our constructors. We have no R constructor. We have constructors with various arguments or parameters. Can have the same name but cannot have the same signature. Method overriding happens only when you have inheritance or when you have extending a class. This occurs when the child and the parent both have a method with the same name and the same method signature. So that same method exactly, name and signature, exists in both classes. The child class will override the call of the parent method. Archibald calls this the thanks but no thanks method call. So there is a toString, for example, in vehicle, but when there's a toString in car, car doesn't use the toString in vehicle. It says, thanks, but I'm going to use my own. But if the child car does not have a matching method, then the method from the parent is run. Then the method from the parent is run. In inheritance, we need to remember capital object and lowercase object. Capital object, for lack of better words, is the granddaddy class. It's the top of the pyramid, it's the root. All classes inherit from capital O object. If you do not use the keyword extends, it is implied that your child looks like this. Public class, my child extends object. We don't need to have extends objects because it's implied to be there. You can add this, but it does nothing because it's already assumed to be there. Remember in inheritance, you need the keyword extends. Remember in inheritance, you're going to have a parent class and a child class. You're going to be using the call to super. We must modify the constructor in the child to call the constructor in the parent. So the child has everything in the parent and everything in the child. In inheritance, we're going to be using method overriding. We could still be using method overloading, which we've learned in composite classes. Each class should be self-contained. So when I build a class, it should have all the behaviors and all the fields within it. All methods should be perfect. This is required because when you extend a class, you would just use it without edits or changes. So if I extend vehicle, I expect vehicle to work perfectly so that I can just use it. All right, that's a pretty long time, so we're going to pause. Hopefully, you will be experimenting on your own.